Hi guys, good evening. Am I audible to everyone? Let me just check on those who joined to YouTube and check if I'm audible to them also.
Docker help with production quality applications? And how do you build your own Docker file from scratch?
After joining from YouTube also. So today I plan to start with the trees. Okay, as I give you a heads up last Thursday that linear and non-linear data structures. So among the non-linear data structures, very widely used is trees. So let's try to kick off with what is how to work with trees. Let me know once you're able to see my Eclipse paint screen. I'm drawing something over here. Is the paint screen visible to everybody? Particularly those who have joined through Zoom can confirm. But Vignesh, Devang joined. Yes. Devang, is the paint screen visible? Oh, thank you. So trees. So how we draw a tree? Okay, we have many types of trees. Basically, the two most famous are the binary tree and the binary search tree. Yeah, so we call this as BT and we call this as binary search tree BST. So BT, if I take a set of array, let's say, okay, any random order, if I take the array elements, okay, so let's say these are my elements and I need to form a binary tree or a binary search tree, both with this data set. Binary tree, the first element becomes the root, like how we have head in linked list. In tree, we have root. So the root is the first element. Now, the next element will go towards the left of the root. So we'll go at 50. And the next element will go at the right. 70. Okay. And then like this, it will spread organically left, right, left, right. So 200 will go towards the left of 50. And 175 will go towards the right of 50. So we draw it in a way that it should look a part of the left subtree. Like this. So we should make sure that you draw the tree in a way that it should look part of the left subtree. 200, 175. Then 150 will go towards the left of 75. So I'll break it further more over there. And 25 will go over here. So it goes organically left, right, left, right, left, right. So if I have to add 125, I know 125 will come over here. Like this. Left, right, left, right. So it's a height balanced tree. But this is not the case with binary search tree. Binary search tree will look for an element. If it is greater, it will go towards the right of the root. If it is less, it will go towards the left of the root. So first I add the root. If there is no root, it's a null tree. Then the next element is 50. I check with the root. Is 50 less than 100? Yes. Then it goes towards the left. Next element, 75. So create the element over here. 75, like we would make in the factory. Now once that element is shifted or shift to the site, I will compare it from the root. 75 compared with 100 is lesser, will go towards the left. 75 compared with 50 is greater, I will put it towards the right like this. So put it toward the right such a way that it looks it is greater than 50 or it is less than 100. Now which is the next element to be added? 200. So for the factory I will get the node 200 and then I will compare with always with the root. So here how you would start from the head, now I have to start from the root. 200 compared with 100 is greater and there is no element at the right of my root. So I'll place this over there directly. Then next is 175. So 175 compared with the root is greater, will go towards the right. Compared to 200 is left, will go towards the left. Like this. And I have 150. So 150 first compare with the root. Greater, go towards the right. Smaller, go towards the left. Smaller, go towards the left. Like this, your binary search tree doesn't grow organically. It grows in any one side depending on the data. Then 25. So where do you think we'll put 25 at? 25, I'll place it compared with the root. Lesser, go towards the left, lesser, and then nothing at the left hand side, add it over here. And then 125 will go further towards the left of 150. Right? So such a tree is called as a binary search. And in programming sense, we represent it by a doubly linked list. Okay, so if I take this binary search tree and I want to represent it in the programming sense, I will make a doubly linked list. So data left, right, and this is 1000. We will point to it and then add the data. So for the factory, I'll get the data. So the factory, I'll get the node with the left and right as null and data as per whatever the customer has entered. This node is delivered to me and shift to the site, and then my site engineer has now pointed to NN. Okay. So before this, there was no tree. So my root was null. So root null means it's a null tree. no tree at all. So root was null. Now I've got the first element. So now I've got one element. So now my root will not be null. So now my root will point to 1000. Now whenever I will ask for the next node, 50, I will send this data to the site factory that please give me a node with 50. So it will place the node with 50 and left right as null and deliver that node to my site. Now I know this node will go towards the left hand side. So I try to place it over here. And now who will receive this NN? So NN which is pointing to 1000. Now will come to 2000. Which the other new node has been shipped. And now I will compare if the data of my NN is less than the data of my root. So if the data of NN is less than or equal to the root dot data. So what will I do over here? So in this case, it is true. NN dot data, right? NN dot data 50 is less than or equal to 100. True. Come inside. Okay, once I come inside, I will first check, do I have this, there is space to add over here. So I will check that it is lesser, I'll check in the left part. So if my root dot left is equal to null, which it is right now, right? Which is just true. So I will come inside and I will add in the root dot left, I will add NN. If it was not, then I would have gone into else, and then I'll show you what to write, what code to write in the else part. So yeah, this was true. So now my root dot left becomes NN becomes 2000. And now my root links over here. This left part links over here. If is there, it will not go in this else. It has gone in this if. It will not go in this else. And the loop will continue. Okay, loop will continue. I just write this code over here so that you can draw parallel. Okay, then it gets the next element, so it orders to the factory that please get me a node with 75. So it puts null 75 and null and delivers this to the site. I know this will come at over here, right? So geographically place it over here and the address will be 3000. We will point to this 3000 and then now let's come on this again. NN dot data, is it less than equal to root dot data? That is 75. Is it less than equal to 100? Yes, correct. Root dot left, is it equal to null? No, it is not null. So now go towards the left, recursively iterate. Okay. So now what I will do is, yeah, so this is my insert function. And I'm inserting, I'm calling the root and the NN as a parameter. my insert function. I will recursively again call the insert function now. And now we'll check that. Now this will be, the left part will become the root now. So root dot left is your new root and NN remains the same. So now what is my root? Now my root for this insert is 2000. Okay. So I'm just add for the sake of addition. I'm just changing this. So now the root is 2000. It will not change. You can take a copy of this variable. Yes, the original root will not change. So now root is 2000 and then is 3000. Again it goes up. NN dot data 75. Is it less than or equal to 50? No. So we'll go in this else now. Now what to do? So as it has gone towards the right side, I will check in the right. If root dot right is equal to null, which it is. At the moment it is null. This is null is there. So what to do? Root dot right equals to null. So I'll just place over here 3000. And this gets added over and was removed from there, right? Like this here. Okay. Now let's try to add in the else ka left. So let's say if I would have if instead of 200, I would have something called as 60. I've got something called as 60. Now how would we add this 60? So first I would request from the factory that please give me a node with 60. So it will go here and prepare a node with 60 and ship it to the site. This node will come here. I know to be placed over here, right? So don't point to it. Actually 4000. Don't point to it NN. All the insert function with root and NN. Again, the root will go back to the original root. So the root will be fixed 1000. Now, NN arrow data, it is 60. Is it less than the root? Yes, true. Root dot left is it null? No. We'll go again call the insert function with root dot left as your root now. So now the root becomes 2000. NN is 4000. Goes up. NN dot data 60. Is it less than root dot data 50? No. Okay. So first we will compare NN dot data. It is 60. Is 60 lesser than 50? No. We'll go in this else now. Root dot right is it equal to null? No, it's already there, right? So we'll go in else. Then what will we do? Call the insert with now root dot right as your root and NN will be the same. What will this do now? Call insert with root dot right. So what was root? 2000. Right of 2000 is 3000. Now root becomes 3000. Goes up 60. Is it less than equal to? Now root is 3000. 75. Is 60 less than equal to 75? Yes. And is root dot left null? Yes, it is null. So here you can add 4,000. So this way it will keep on creating the list and we will get the entire list at the end. So what we can do is I'll revert back to 100, 50, 75, and then here was 200, right? I'll revert back to 200. So we'll create the list from here. So we'll store all these numbers in an array and then we'll convert this array into a binary search tree. Okay, then once we convert into a binary search tree, we will traverse this array also. We'll traverse this array. Okay, so for tree traversal, we have three techniques. Okay, so here now we have three things, right? Orange is the left, green is the data, and blue is the right. So we have left, data. Every node will have these three attributes, right? So the tree traversal techniques, how we can visit each node of a tree. We call them as tree traversal techniques. Yeah. Pre-order, in order, and post order. So what you do is you just write left, right, left, right, left, right. Okay, you write left, right, left, right. In pre means you put the data before. In means you put the data in between. And post means you put the data at the end. So if I want to traverse this list, this tree in pre-order traversal, so I'll copy the tree. Paste it. Then I will traverse this tree for you guys. So I'll paste this tree. So if I want to traverse it in pre-order, what do I need to write over each node? DLR. So I write what? DLR. I write DLR above each of the node. DLR, DLR, DLR. Okay. So now I give you a cheat code. So if you come across data, that is D. So means cut and display. See, cross data, cut and display. Okay. If you come across L, cut and go. Come across R, cut and go. Okay. All cut, go to parent. Okay. So let's try this. So let's try to traverse this. Data is there. So cut and display. Cut it and display. 100. Then left is left there. Yes or no? Okay. Better we can use this. If the answer is yes, cut and go. If the answer is no, cut and wait. All cut, go to parent. Yeah, same. So now data, cut and display. Left, does this node have a left? Yes or no? Yes. So cut and go. So I go here. Data is there. Cut and display. So I'll have 50. Left is there. Yes. Cut and go. Data is there. Yes. Cut and display. Left is there. No. So the answer is no. Cut and wait. Cut and wait. Right is there. No. Cut and wait. All three cut. Go to parent. Right is there. Cut and go. Data is there. Yes. Cut and display. Left is there. No. Cut and wait. Right is there. No. Cut and wait. All three cut. Go to parent. All three cut. Go to parent. Right is there. Cut and go. Data is there. Yes. Cut and display. Left is there. Yes. Cut and go. Data is there. Yes. Cut and display. Left is there. Yes. Cut and go. Data is there. Yes. Cut and display. Left is there. Yes. Cut and go. Data is there. Yes. Cut and display. So I have traversed the entire elements. So there are 1, 2, 3, 4, 5, 6, 7, 8 elements. I have traversed all 8 elements. This was your in order traverse. So if I take the same binary search tree and try to do a post order traverse. That. So in post order, what will I write before every node? Post order means LRD. So I'll write what? LRD above each node. Okay. So let's start. Left is there, yes, go there. Left is there, yes, go there. Left is there, no, cut and wait. Right is there, no, cut and wait. Data is there, yes, cut and display. So post order, I'll just write it over here. $25. All three cut, go to parent. Right is there, yes, cut and go. Left is there, no, cut and wait. Right is there, no, cut and wait. Data is there, yes, cut and display. 75. All three cut, go to the parent. Data is there, yes, cut and display. 50. All three cut, go to the parent. Right is there, cut and go. Left is there, cut and go. Left is there, cut and go. Left is there, cut and wait. Left is there, no, cut and wait. Right is there, no, cut and wait. Data is there, yes, cut and display. 125. All three cut, go to the parent. Right is there, no, cut and wait. Data is there, cut and display. Right is there, no, cut and wait. Data is there, yes, cut and display. Then right is there, no, cut and wait. Data is there, yes, cut and display. All three can go to parent. Data is there, yes, cut and display. 100. This is your post order travels. Then we have in order travels. Okay? That is very simple. If you will observe, in order will always give you an ascending order. In order will always give you the output in ascending order. So if you are in order, as the name suggests, it is always in order. So we'll give you ascending order travels. What do we have to write on every node? LDR. Left is there, cut and go. Left is there, cut and go. Left is there, cut and go. Data is there, cut and display. So we'll display you 25. Right is there, cut and wait. All three cut, go to parent. Data is there, cut and display. Right is there, yes, cut and go. Data left is there, cut and wait. Data is there, cut and display. 75. Right is there, no, cut and wait. All three can go to parent, all three can go to parent. Data is there, cut and display. So if you observe, it is going in ascending orders. So for your min heap, max heap, we try to use this. Right is there, cut and go. Left 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 is there, no, cut and wait. Data is there, cut and display. Right is there, no, cut and wait. All three cut, go to parent. Data is there, cut and display. 150. Right is there, data is there, yes, 175. Height is there. Yes, cut and go. Data is there. Yes, 200. So like this, it will traverse it in. So this is the way you can display the list. Now let's create the list and try to display it in our Java program. Okay, so we had made a application over here to be the day 14. New package day 14. So let's make a W linked list node. So I had last time made a W linked list node, W. Okay, so node is there. Let's copy this node back over here. So I'm using the same node which I used for W linked list, previous, data, and next. So but here I will call it as left, data, right. Okay. I'll call it left, data, and right. Now let's go to the binary search tree creator. I'm sharing my Eclipse here. I hope you all are getting my visible. My Eclipse is visible to everybody. Okay, I just copied the node on the W linked list, and I'm just changing the previous to left and next to right, the left data right. Left data right. Let's go and create a new class, binary search tree demo. Okay. So let's main. So let's first take the root initialize to null. Okay. Then we'll call the create function, pass the root to it, and it will give us the new root. Good. For the same ideology. This create function, is it there? Not there, so we'll create this. So here you can do a do while as long as you want to enter. Okay, so we'll take a scanner over here. SC is new scanner and system dot in, and every time you will ask the user to add more elements. Okay, so we will say 1 for yes and 0 for no. And then we'll scan that into the integer choice sc dot next int, and I will run this while my choice is equal to 1. So while my, so we'll take, because it's variable over here outside. So do you want to continue add more elements? As he says 1, I will enter, and while he says 1, the loop will continue iterating. Okay. So let's come and ask the user to enter data for node. Whatever data he enters, I will call it as info. Next int. Then I will create a new node with this info, and we'll point to it. node NN. So now NN has the new node and root has null. Okay. So now NN has new node and root has null, and now I will call this and pass it to the insert function. What? The root and the NN. That will insert the node form. So let's try to let an insert. So what does insert function do? As I had mentioned over here, this is the logic of the insert. Okay. So what will it check first? The insert function. If my NN dot data is less than or equal to root dot data. Okay. So what will we do? Check in the left side, right? So if it is, then I will check if my root dot left is equal to null. If it is equal to null, I'll put the left as NN. And if it is not, I'll again recursively call the insert function. This time the head will become root dot left and then remains the same. So this is when the left, else will go in the else part, and this all logic will reverse in the else. Okay. So the else entire logic will reverse. I will check for root dot right is equal to null. Then put it in the right part, else I will call insert with the root dot right. So this will be my code for the insert. And once I insert the element, then again I will ask, do you want to add more elements? And this will continue. Okay. Now once I have inserted all the elements, then I will go and check for the traversal. So let me do a in order traversal. Okay, let's first do a pre-order traversal. Okay, so let me do a pre-order traversal on the root. Let's create this function. And yeah. So what will we do? As we are going to do a traversal. Because Amar sir has shared you all the attendance. So those who wish to mark their attendance can do so. The link is now active. Okay, so in pre-order, what pattern do we follow? Pre-order, we follow data left, right, right? But data first. So here we will be continuously recursively iterating. Okay, so till my root is not null, we will go. So if my root is not equal to null, so I'll go to data. So data we will display first. Data we will display. So I'll use print and we will display the root dot data, and I'll add a comma. So data is displayed and left and right. So again, I will go to pre-order traversal with root dot left part. And again, I will go with pre-order traversal with right. So like that I can traverse the entire list. So let's try to run this and check if everything is working fine. As per our expectation, right click, then our Java application. So enter the data. Okay, so I will try to use the same data with which we had created. Okay, so let me open up my paint screen. Okay, so I'll put this as the right side and my Eclipse towards the left side. Okay, I hope I am able to see the entire screen. Yeah, I've split my screen into two halves. Eclipse is towards the left and the paint is towards the right. Yes, I hope my entire screen is visible to you all. But I want to now enter the data, right? So my Eclipse is visible to you all, right? And the paint also is visible. Okay, so I'll take the Eclipse and shift it towards the right here. Okay, so everything visible now. So let's both the screens are visible, guys. So enter data for the node. So first is 100. Okay, there is, we are getting an exception over here. Maybe we did not increment a particular pointer. Line number 43. So here, when you are doing insert, nn.data and the root.data. So we have got insert first time when the, okay, your root is null, right? So when I get this, so I have to check if my root is equal to null, directly my nn becomes the root because it's the first time. Else I would always go with the insert, yeah, because the root was null at the first iteration. No? So first time when I got the node, my root was null, I made that as my nn. The nn will go into the root. And if next time onwards, like how we had for the linked list also, first I would go in else and then going forward to go in else. Yeah, okay. Now I guess we are good to go. Run a Java application. So I Windows minimize 100. You want to continue? Yes. 50. You want to continue? Yes. 75. Yes. 200. Yes. 175. Yes. 150. Yes. 25. Yes. 125. And now I don't want to continue. I hope you are seeing my split screen. Now I don't want to continue. I'll enter 0. So it creates the list and it returns me. Okay, I should have returned the. So after this, I have returned null. I should have returned the root. I should have returned the root. Okay. We return the null. We should have returned the root. Let's come again. 100, 150, 1, 75, 1, 200, 1, 175, 1, 150, 1, 25, 1, 125, 0. So the reason I'm entering the same data is because we have the answer for the traversal, no? So see, it is showing me answer as 100, 50. So let me check with the pre-order traversal was the right answer. Just compare it with this one. Pre-order, right? So 100, 50, 25, 75, 200, 175, 50, 25. Absolutely correct. The answer is correct. So I've created the tree also, and I have traversed it. Okay. So you can traverse any of the techniques. Or let me expand my. Okay, so you can traverse in pre-order, post-order, all techniques you can traverse. I'll add the code for all of that. And in order also. In order, it is understood that the answer will be in ascending order. So let's do post-order. So post-order, same logic, but what is the logic for post-order? Data later on. So left, right data. So first the left, right, and then the data will be displayed. That is your post order. And in order, okay. What was in order? In order means data left, right. Left, data right. That was the in order. So left, data in between, and your right. So if you traverse, you will get the answer. Okay, so if I just make a small, okay. So if I just make a small linked list of 4 elements, okay, 100, 150, 1, 150, 1, and 75, and then 0. Okay, so I guess we did not 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we should have prefixed. We should have prefixed this out. Pre-order traversal. Post-order traversal. In order traversal. Now if I make 100, 50, and 200, and 0. So see, in order traversal will always come in ascending order. Okay. So we can always arrange this later on. So if I now tell you all that try to traverse this linked list, and I will give you 2 nodes, I will give you a number, and you display me which 2 are forming the sum. So if I give you a number, okay, which 2 nodes are forming that sum. So let's say I give you 375. 375. Now which 2 nodes are forming 375? So 200 and 175 collectively form the sum 375. So if I want to do that, what will I do? So what I can do is in my application, I take a array list of integer. Okay, and I will say node data is new array list. Okay, Control Shift 4. So when I'm traversing it through any of the mechanism, let's say I traverse it via in order, and the answer will be the ascending order. So whatever data I am getting, I'm also adding it into the node data. Whatever data I am getting, I'm traversing also, and also I'm adding that. Okay, so yes. Okay, I did not save it. So node data dot add. Part of this class, right? So I can access it across any of the. Okay, so it's let's say static variable, let's say. So I can now, here's my in order. So as I am saving, I am saying dot node data dot add the root dot data. So now I have all the elements added back to the, so here, okay, so here I can display that node data as well. So if I run this 150, sorry, see 100, 151, 125, 150, 0. So I have all that. Okay, what happened? Why is it not? We are adding all that data into the list. Yes. Root dot data. So it gets populated every time this one. Okay, guys, it's time up. We'll try to finish this program tomorrow. As to if I give you a number, which two nodes form the sum of that number? So very common question asked in the interview with regards to your trees chapter. Okay, so we run out of time. If we had time, we would have surely completed this. So let's keep it for tomorrow. And yeah, okay, Amar sir then.
Yes, sir, sure. So dear students, I hope everybody marked your attendance. If not, please mark it into the chat box. And tomorrow will be the last day of this program. Thank you. Bye bye. Take care of yourself and take care of your family.